Hi, my name is Kim Espejo, and today we are going to talk about NMR. Okay, so in the last video, the MS and IR video, the structure predicted from going through all the steps was a cyclohexanone. And so we're going to use the NMR spectra of hydrogen and carbon to see if the structure is correct. Okay, so looking at the hydrogen spectra, we see that there are three shifts. There's one that looks like it's at 2.4, 1.9, and 1.7. These shifts could mean different things. In the next image, we will see what these peaks could represent. Okay, so from this little graph, we can see that the 2.4 shift could mean a benzylic structure, and then the 1.9 and the 1.7 shift could mean like a secondary alkyl structure. Okay, so on to the carbon spectra. It looks like there are 4 different shifts, so that means there could be 4 different environments in the structure. It looks like there is a shift at 212, 42, 27, and about 25. Alright, so looking at the little guide for the carbon NMR, we can see that the structure at 212 could possibly be a ketone, and the shifts at 42, 27, and 25 could either be a secondary alkyl or a tertiary alkyl. And that could depend on how high those peaks are in the graph. Okay, so after looking at the graphs, let's go back to the structure and determine the different hydrogen environments. So when looking at the different environments, we have to consider the structure's symmetry, which means that there are going to be less signals, or if it's going to be asymmetrical, which means there are going to be more splitting. So for this structure, it looks pretty symmetrical except for that ketone. So it's not completely symmetrical. There's going to be a split. The first environment is going to be right there, the 2 different areas, and then the next one is going to be the next 2 different carbons, and then the last one could argue that it could be part of the blue environment, but it's different enough where it could have its own environment. Okay, so next we're also going to look at the carbon environment, and we're basically going to do the same thing like we did for the hydrogen one. So the first carbon environment is going to be where that ketone is, because there isn't anything like it on the structure, so that's one environment. Okay, the next carbon environment is going to be those 2 circles in the red. The third environment is going to be the purple circles in that blue hydrogen area. And the fourth and final carbon environment is going to be in that gray dot, the darker gray dot, where that yellow hydrogen environment is at. Again, these environments are all different from one another because of the symmetry of the structure. Alright, so cyclohexanone is going to have 3 hydrogen environments and 4 carbon environments. And we determined that by looking at the NMR graphs, spectras, and also looking at the symmetry of the actual structure. Alright, so the last thing is to compare the spectra with your structure by doing the n+1 rule. So I'm going to look at one of the blue hydrogens, and so it looks like there are two environments next to them, or it can see two different environments. So my n is going to be 2. You're going to add 1 and it's going to equal 3, so that means there are 3 environments. I'm going to circle all of that and then look at the graph and see that yes, there are 3 different shifts on the graphs and 3 different environments. So my structure is pretty spot on.